Hello friends, myself Drishya, working as an assistant professor in SNS College of Technology. Here we are in the subject Design Analysis of Algorithm 23 CST 204. So the introduction part. Hope all of you understand about the basics of algorithm. What is the algorithm? What are the specifications of algorithm and the types of algorithm, representation of algorithm and advantages. So today we are discussing about the one of the important topic in DAA, that is asymptotic notation. This is the mind map. We already discussed the all the topics included in data design analysis algorithm is shown here. So what are asymptotic notation? We are going to the topic asymptotic notation. Asymptotic notation are used to analyze the performance of algorithms, which is help to showing or analysis of the performance of algorithm. For that, we using asymptotic notation. They describe how time or space complexity grows with the input size. Then common notations are big O notation, omega, then theta notation, little o, etc. What is asymptotic notation means? It is used to analyze the performance of algorithm. The types of asymptotic notations are big O, omega, theta. Then, why asymptotic analysis? Why we are using the asymptotic analysis? It is one of the major topics in design analysis algorithm. We have an algorithm. Algorithm is a step-by-step procedure to solve a problem. So, for solving this problem, we need to we need to reduce the space and time. So, we want to easily solved a problem and find out the solution. So why asymptotic analysis is ignore constant factors and lower order terms, focuses on growth rate for large inputs, helps select the most efficient algorithm, machine independent performance evaluation. This is the asymptotic analysis importance here. First we are going to the first type of notation, that is big O notation. It is order of big O is represented using the letter of f of n. Definition of big O notation is it is represented using upper bound and lower bound. Okay, so we are this is a representation of big O analysis. This is the graph representing big O analysis. Definition is represents the upper bound of an algorithm's running time, then describes the worst case performance. The formal definition is the function f of n is equal to the order of g of n if f of n less than or equal to c of g of n for all n greater than or equal to n0, where the c is a constant, c greater than 0, which means algorithm will not take more time than g of n. So this is the upper bound g of n and the lower bound f of n, the middle is c of n. This is the representation of this is the analysis of big O notation. The big O example is the algorithm time complexity. Linear search is order of n. Binary search is order of log n. Bubble sort is order of n square. Merge sort is order of n of log n. You should by heart and understand how the time complexity is like this. So the example is f of n equal to 3n plus 5, which means the order of n. Here only one is only one n is used, so the time complexity is order of n for big O. So the next is omega notation. It is the letter omega f of n. It represents the lower bound of an algorithm's running time. It describes the best case performance. The formal definition is f of n, the omega of g of f of n equal to, f of n means the function f of n equal to omega of g of n if f of n greater than or equal to c of g of n for all n greater than or equal to n0. You should by heart and understand the notations representation or the formal definition, which means algorithm will take at least g of n time. The next is the theta notation. It represents the tight bound combines upper and lower bound, upper and lower bounds. Formal definition: f of n equal to theta of g of n if c1 of g of n less than or equal to f of n less than or equal to c2 of g of n. The meaning is which exact growth rate of algorithm. The example is given theta of n square. This is the graph representing the upper bound is c1 of g of n, the lower bound is c2. Our function is in the middle one, so it is tight bound combines upper and lower bound. This is the comparison, and this is the graphical interpretation of or omega or big O and theta notations. Hope all of you understand about the big O notation and theta notation, omega notation, which is collectively known as asymptotic notation. It is one of the important topic in design analysis algorithm. It's for using reducing the time complexity and space complexity. So thank you.